What is data oriented programming and how Java supports it? Well, data oriented programming is a programming paradigm that is oriented toward data, or we can say a way of modeling programs that are focused on data instead of behavior of individual functions and objects. So it's not a replacement of object oriented programming, particularly in Java. It's a relatively new functionality that add new features to Java and its existing functionality and help us to write programs that can manage data to optimize memory access patterns and cache locality. And these techniques fit perfectly with the object oriented programming. So we can say while OOP encourages us to model complex entities and processes using objects, which combine state and behavior, data oriented programming encourages us to model data as data and keep the code that represents the business logic of how we act on that data separately. So as we know that programs are now becoming more and more smaller, the days of monoliths have almost gone. And these days we compose larger applications out of many smaller services. So while programming earlier, our emphasis was on using classes to model large business entities and long lived processes. These days, with smaller services, our emphasis is more on using classes to model data. Now, the question is how Java supports it. So, there are certain new features that have been introduced in the recent versions of Java, and they help us to provide a support for the data oriented programming in Java. So, as this trend toward smaller programs has progressed, we can say that Java has developed the new tools to make it easier for us to model data as data, that is, records, and the way to directly model the alternatives, the sealed classes, and then the ways to flexibly destructure polymorphic data using the pattern matching features. So, records, sealed classes, and pattern matching are designed to work together to support data oriented programming in Java. Records allow us to simply model data using classes. Sealed classes let us model choices. And pattern matching provides us with an easy and type safe way of acting on polymorphic data. Now, let's talk about the records first. JDK introduced records which are a new kind of type declaration like an enum. A record is a restricted form of a class. It's ideal for the plain data carriers kind of scenario for the classes that are primarily used to store and represent the data. So records are similar to traditional Java classes in that they can have the fields, the constructor, and the methods. But they have some important differences that make them well suited for the data oriented programming paradigm. One of the key features of records is that they automatically generate useful methods like equals, hash code, and toString based on their field values. This means that records are immutable by default and can be used to represent data without requiring a lot of boilerplate code that we used to write earlier. Records also provide a concise syntax for declaring fields, which can be declared in line with the record declaration. For example, a simple code in Java to declare a record for, let's say, point look like this. It is just one line of code that you need to write that. In this example, the record has two fields, x and y, both of type int. The record also has a constructor that takes two parameters, one for each field. So records can be used in many situations where simple data structures are needed, such as representing data from a database or JSON response. Next, we have sealed classes. Sealed classes, as we know, allow us to restrict the inheritance hierarchy of a class. or interface. Sealed classes and interface restrict which other classes or interfaces may extend or implement them. To seal a class or to define a class as a sealed class, we add the sealed modifier to its declaration. Then, after any extend and implement clauses, and then we add the permits clause. This permit clause specify the classes that may extend the sealed class. So, for example, if you want to declare a sealed class shape that look like this, you simply declare the class as a sealed by specifying the modifier sealed before its name. And then with the help of the permits clause, we specify what all classes are allowed to extend from this class. So in this case, circle, square, and rectangle are allowed to extend from the class shape. Now the question is, how does that help in data-oriented programming? Sealed classes can help in data-oriented programming by providing a way to define a closed set of classes that can be used to represent data. This can help ensure that the data being manipulated is consistent and well defined, which can lead to more efficient and optimized programs. For example, through this code, we are declaring a sealed class to ensure that the program only operates on well defined shapes like circle, square, and rectangle. And then we can use the pattern matching and exhaustiveness checking to ensure that all possible shapes are handled correctly. This can be specifically useful in data oriented programming, where our focus is on optimizing the storage and manipulation of data. By using sealed classes to define the data types, you can ensure that the data is well structured and can be efficiently stored and manipulated. Next, we have pattern matching. Pattern matching involves testing whether an object has a particular structure and then extracting data from that object if there is a match. Pattern matching, as we know, is a useful tool and it helps in data oriented programming as well because it provides a concise and efficient way to match patterns in data structures like collections or records. This can help simplify and optimize code that manipulates data and can make it easier to reason about the behavior of the program. So we can say that records, sealed classes, and pattern matching provide a way to implement data oriented programming in Java. And this entire approach to data oriented programming is based on three key principles. Code is separated from data, data is immutable, and data access is flexible. Now, how does it look like in action? And what differences does that make in real life? We'll try to cover that in the next part.